Yeah.
Alright. So is this the one we're on? So solving the initial value problem. That's the same thing as basically saying, give me the antiderivative. So here is my derivative. X to the fourth minus 3x plus 3 over x cubed. How would we write that? So if we do our antiderivative of x to the fourth would be what? Minus antiderivative of 3x would be 3 halves x squared. Okay, here, if you add 1 to the exponent, you get x to the negative 2. So we need a negative 1/2 in front. Times my 3 would give me a negative 3 halves. Plus c. Alright, so now f of 1 equals 1. So if we put in a 1 for our x, this would allow us to find our c. So we get 1/5 minus 3 halves plus c, and this has to equal negative 1. All right, so you guys help me out. What's this turn out to be?
So 2 no, 2 before this. Or negative 2. No. Hold on.
Is it negative 13 over 10?
Oh, 4. Negative.
No. Okay. 1/5 minus 3 halves minus 3 halves. What's that give me?
My calculator says negative 14.
Thank you. I had a calculation error. See, I'm all flustered because my morning didn't go as planned. All right, add over my 14/5, so negative 1 plus 14/5. Give me 9/5. I think I did that math right. So, my initial value problem, that's just saying what's the initial equation. So 1/5 x to the 5th minus 3 halves x squared minus 3 halves x to the negative 2 plus 9/5. All right. Any questions there? So let's look at this one. The graph of a function is given. Make a rough sketch of the antiderivative. Ooh, we spent all this time graphing derivatives. Now we have to think the other direction. Given that f of 0 is equal to 2. So if f of 0 equals 2, I'm giving you a starting point. Okay, so on my original function, when x is 0, it's going to equal 2. All right. So if I'm doing the antiderivative, that means what I'm looking at is the derivative. If the derivative was negative, what did that tell me about my original function? It was decreasing. Okay, so it had to be falling. Now when my derivative is 0, what does that tell me about my original function? I had a min or a max. So if I'm decreasing, that had to be a min right there. Then my derivative was positive, so that meant my graph was increasing until we get to 3. And at 3 it was 0 again, so we have to have another max or min. Okay, then my graph is decreasing or my derivative is negative, so my graph has to be decreasing the whole time. It never hits 0 again, so that means I don't have any other maximums or minimums. But what's happening right here? If it's flattening out, what's that telling me about my function? At a slower and slower rate, so it's kind of like a horizontal asymptote. It's decreasing, still decreasing because the derivative is still negative, but less and less. Let's look at a few more. We may not do all of these examples. I put several in here, but let's remember about motion. So we know position, velocity, and acceleration. The first function is position. If you do the derivative of that, you get, did I usually call it S for position? So the first derivative is velocity. Second derivative would be so we know how these things are related. We're used to starting with a position function and working our way down to whichever one we need. But now that we know a little bit about antiderivatives, we could really start with any of them and figure out the others, so no matter which way we had to go. So let's look at this one. Find a particle's position function x of t for a of t equals 10 minus 30t, x of 0 equals 5, and b of 0 equals negative 5. So we have our acceleration. How do I get to position from here? The antiderivative. So when I do the antiderivative of acceleration, what's that going to give me? Velocity. Okay, so the antiderivative of 10 would be 10, we're using t for the variable on this one. It could be x's, but since I set up here t's, we'll stick with that. Minus the antiderivative of 30t. Plus our constant on the end. Can I find my constant? Yes, we know that v of 0 equals 5. If I put in 0, I get 0 minus 0 plus c equals 5, or negative 5. So my constant is negative 5. So the velocity function, 10t minus 15t squared minus 5. All right, but I didn't ask for velocity, I asked for position. So we have to just go backwards. You can call this S, sometimes it's also called x of t, it doesn't really matter. What's the antiderivative of 10t? Minus, what's the antiderivative of 15t squared? Minus the antiderivative of 5. 5t, and then we would need plus a constant. You could call it c. I'm going to put k since I already used c up above. Can I find out what that constant is? Yes. We know that my starting position, so if I put in zeros for everything, has to equal 5. So in this case, that means k is 5. So my position function, you can call it x of t, you can call it s of t, whatever you like. Would be 5t squared minus 5t cubed minus 5t plus 5. want you guys to read the next question. See how far you can get. So a particle starts from rest. This is the piece that most of you were missing. If it starts from rest, what is the velocity at time 0? 0, because it started at rest. At the point x equals 10, so that's our beginning position. In this, we're using x for the position label. That's just what the problem told us. Our time is t. So at time 0, my position was 10. All right, I know my acceleration. So velocity would be the antiderivative. The antiderivative of 12t would be plus a constant. But we can find that because we know it started from rest. So my beginning velocity has to be 0. So if I put in a 0, that just tells me my beginning constant is 0. So velocity is 6t squared. So then position, you can call it s. I'm just going to stick with x because that's what the problem called it. So the antiderivative of 6t squared would be plus another constant. I'm just picking k since I already used c in my problem. And I know that when my time was 0, my beginning position was 10. So that means the k value is 10. So our position is 2t cubed plus 10. Any other questions? All right, try this one. All right, so a particle moves along a straight line and has the acceleration 6t plus 4. We have the initial velocity, initial displacement. So this time they went back to using s for the position function. You'll see both, so it means the same thing. So our velocity, antiderivative, would be 3t squared plus 4t plus a constant. We know that if we plug in 0, this will just be c, which is -6. So the velocity function, 3t squared plus 4t minus 6. All right, and then we need position. So that would be t cubed plus 2t squared minus 6t plus a new constant. And it tells me if I put in a 0, so that would just give me k, and that equals 9. So we get t cubed is 2t squared minus 6t plus 9. Looks like we did pretty well with that one. So I'm going to do, I think, maybe one more, and then we'll stop for today. Okay, a ball is thrown upward with a speed of 48 feet per second from the edge of a cliff 432 feet above the ground. Find its height above the ground. So finding the height, that's the position. That's what I'm asking you to find. T seconds later, using the fact that acceleration due to gravity is -32 feet per second. So it's telling me my acceleration is -32. So velocity, what would be the antiderivative? Plus c. Okay, how can I find out what c is? That was our starting speed, or our starting velocity was 48. So if we plug that in, that means the C value is 48. Okay, position. Antiderivative of negative 32t would be negative 16t squared. It's 48t plus a new constant. How can I find out that constant? Yep. Since we started at the beginning, we were at a height of 432. That tells me my K is 432.
Speed.
Uh-huh.
You said eight, X is
Mm-hmm.
is that, is auto
So it didn't say the speed after 1 second was 48, it just said we threw it with the speed of this, so the force coming out of our hand. And it was a positive because it was going up. If I had dropped it or thrown it down, then it would have been a negative velocity to start with. Okay, so now we found the height function. Then I asked other questions, just because we've done some of these types before and I wanted to make sure we remembered. When does it reach its maximum height? If it reaches the maximum height, what does that mean? The derivative. What's the derivative of position? The velocity. So my maximum height is just when my velocity is equal to what? I get 3/2 or 1.5 seconds. All right. Final question, just really seeing if we remember all the things. When does it hit the ground? What would I have to do to find when it hits the ground? Our position. Equals 0. I think we could divide by negative 16. Is anything multiply to negative 27 and add to negative 3? Nope. So what do we do? Quadratic formula. Oh, look, this is a problem that just keeps getting.
I love this problem so much.
It is amazing. So the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Look at all the review we're doing just in one problem. All right. So I get 9 plus 108. Let's go ahead and just get a decimal approximation, because if we're giving time, we would probably want a decimal anyway. So if I do 3 plus the square root of 117 divided by 2, I get 6.91. If I do 3 minus, I get negative 3.91. So which one would it be? The positive. So it takes 6.91 seconds to hit the ground. probably not gonna give you one that asks all of that on your homework, but the antiderivative stuff is definitely fair game. Any questions for me? Okay, so yesterday I posted a handout. You should have time to finish that.